Hey everybody. Yeah, it's actually me. It's not Miss Dwyer. So what we're going to do today is do 3 quick examples about expanding logarithms and then common bases and how we can use those to simplify and solve some problems. So we've got 3 different problems. Find the numerical value of the log expression. Now if you notice, they give us the log expression and then they give us what each log expression is equal to for a specific number. So like the log of A is 6, log of B is negative 10, log of C is negative 8. Well, those are facts, right? We're going to use those facts to solve this value here. Now notice, I don't know what the actual value of A is, so I can't plug in A, but I know that the log of A is 6. So we're going to take the idea of expanding logarithms to simplify this process. So I did this in a couple of steps. First thing we're going to do is we're going to expand. Well, if I have the log of a fraction, I'm going to take the log of the numerator and the log of the denominator. So that turns into the log of C to the 5th power. Now notice, log of C is negative 8. I have to use the property to deal with that 5. I can't just plug in negative 8 right away. And then I don't know what the log of A times B to the 3rd is, so I have to use that property as well. But you'll notice I did one extra thing. See this square root? Remember how the square root can be rewritten as the exponent 1/2? So what I'm going to do first is I'm going to take the fact that I've got this 5, and we're going to use the property of logarithms that said, let's take that 5, and if it's an exponent, you can drop it down right in front. Now there's 2 different ways to do this one. Notice I've got A to the 1st and B to the 3rd. What I actually need to do is I need to distribute this 1/2 first. So think of this A as really A to the 1/2 and B to the 3/2. So then what I'll do is for the denominator, I'm going to rewrite this using the property of logs that says if I have 2 items that are being multiplied inside, we can rewrite it as the log of that power, A to the 1/2, plus the log of B to 3/2. So I decided to write that out as the addition of 2 logs. And now, my next step, notice how we have the 1/2 and the 3/2 are in the exponent, just like the 5 was. We're going to drop those out in front for the next step. Now what's beneficial in doing that, right? What I did was I got the log of C by itself. Wait a minute. I know what the log of C is equal to. I have the log of A all by itself. I know what the log of A is equal to. And I have the log of B, which we know what it's equal to. So once you use your properties of logarithms to expand and write them as a single log expression without any exponents, you can then replace exactly what they're equal to, right? Log of B is negative 10. Log of A was 6. And log of C is negative 8. And now it's just an algebra problem that you need to simplify. So 5 times 8 is negative 40. Down below, half of 6 is 3. So I think of this as 3/2 times 10 over 1. So 3 times 10 is negative 30. Divided by 2 is negative 15. And then we get negative 40/12, which reduces down to my final answer of 10/3. So that's what you're going to do for one of the assignments here in Delta Math, is expand, get it to the spot where you know the singular logs, and then plug in their values and simplify. All right, let's try this one. Oh, I revealed the answer quick. So what do we want to do now? Well, in this case, we have to solve, but notice we don't have logarithms, we just have exponents. So there's a couple of different thoughts on this, but one of the thoughts that we can do is we can rewrite each base. So rewrite this function so each base is exactly the same. Here's what I mean. Well, wait a minute, 36. Isn't there another way to write 36? We can write 36 as 6 squared. Now notice, it's still 36 to the 4th power. I'm going to think of that as 6 squared to the 4th power. And then we have our properties of exponents. A power to a power tells me to multiply. So this really becomes 6 to the 8th power. Now, here's the theory behind this. If both bases are the same, if these are truly equal, that means the exponents have to be equal as well. So we drop out the bases and we say 8 has to equal 3x plus 2, and now it's a much friendlier algebra problem. All right. Now, if you're curious if this is true or this works, what you can always do is you can take your answer of 2, plug it in right here, and do 2 times 3, which is 6, plus 2, which is 8. So do 6 to the 8th power, and does 6 to the 8th power equal 36 to the 4th power? If the two expressions are equal, then you know that this is a correct answer. So let's try one more here quick. And notice this one looks a little scarier. So what you're going to have to do here is you're going to have to play around and try to figure out what are some good numbers to use with 216 and 1296. So let me show you what I did with with my calculator here. Is I took the base 216 and I decided, well, what's the square root of 216? It's not a friendly number. And then I took the cube root. If you're forgetting where the roots come from, remember the math button? You can do the cube root. Right here is option 4. But what if I want to try like the 4th root? I will use the cube root because that was friendly, but let me show you the 4th root. How to do that is you'd have to type in the number first. Then you're going to go to math. And let's try the 4th root. So option 5. See how that 4 is the index number? And if I do 216, that's not really a friendly number. So I'm going to focus on the fact that I know that 6 to the 3rd power gives me 216. Right? So I'm going to take that piece, and I'll show you half of the answer here. So I can take 216 and replace it by 6 to the 3rd power. But what about 1296? So, how many times does the 6 go into that? There's a couple ways you can do this. You can do 6. We know that 6 to the 3rd power is 296. So what's 6 to the 4th power? So I'm kind of doing guess and check here, and notice 1296. So 6 to the 4th power is going to give me exactly what I need to solve this problem. So I rewrote 216 as 6 to the 3rd power. I rewrote 1296 as 6 to the 4th power. Now notice we have the same base, but we have a power to a power that we have to take care of. I maybe shouldn't have done this. I probably should have added in one extra step here. But the power to a power rule tells us we are actually going to take this 3 and it is going to multiply all pieces of the exponent. So 3 times 3 gave me 9x. 3 times 3 gave me 9. And then here we've got 4 times 2x, which is 8x, and 4 times 5, which is 20. So you have to do that in order to get the bases exactly the same. And once the bases are the same, the only way these two items will be equal is if their exponents are the same. So all we're going to do then is set the exponents equal to each other. And now it's algebra. Subtract the 8x minus the 9. So if I bring the 8x over here, 9 minus 8x is 1. Subtract the 9. 20 minus 9 is 11. And that tells me that x equals 11. If you were to check, if you put 11 in for x here and 11 in for x here and checked, you should get both sides equaling the same value. Just remember, if you are just typing everything all at once, you always have to put the exponents in parentheses. All right, so that's all I got. Go ahead and try the Delta Math video. Next week, we're going to do a little quiz and a test coming up on Friday of next week. Adios.